Dear students, do you want to get into the fascinating world of physics? Please see this video and also subscribe to this channel.
Six-ray optics. There are two ways of spreading light: to be the candle or the mirror that reflects it. Edith Wharton Learning. In this unit, the students are exposed to the ray aspect of light, the phenomenon of reflection and refraction of light, the determination of speed of light, the concepts related to mirrors, lenses, prisms, etc., the different phenomena like dispersion and scattering of light. Introduction 6.1. Light is mystical, yet its behavior is so fascinating. It is difficult to comprehend light as a single entity. The ray optics deals with light that is represented as a ray traveling in straight lines.
Here, the geometrical constructs get the permanence to understand some of the characteristics of light and the phenomena associated with it. There are several other phenomena which can only be explained using wave optics, which we study in the next unit. There is also a quantum aspect of light which we can study as quantum optics in graduate level courses. 6.1.1 Optics. Light travels in a straight line in a medium. Light may deviate in its path only when it encounters the boundary of another medium, or an obstacle. A ray of light gives information only about the direction of light. It does not give information about the other characteristics like intensity and color of light. However, a ray is a sensible representation of light in ray optics. The path of the light is called a ray of light and a bundle of such rays is called a beam of light. In this chapter, we can explain the phenomena of reflection, refraction, dispersion and scattering of light, using the ray depiction of light. 6.1.2. Light. The bouncing back of light into the same medium when it encounters a reflecting surface is called reflection. Of any polished surface can reflect light. Mirrors which are silver-coated at their back can reflect almost 90% of the light falling on them. The angle of incidence I and the angle of reflection R are measured with respect to the normal drawn to the surface at the point 112_physics_vol2_unit6_m.int 1 the 26th of December 2022 11:37 and 18 seconds. Of incidence of light. According to laws of reflection, I, the incident ray, reflected ray and normal to the reflecting surface are all coplanar, i.e. lie in the same plane. 2. The angle of incidence I is equal to the angle of reflection R equals R. 6.1. b. The law of reflection is shown in figure 6.2, a. Regular and b. Irregular reflections figure 6.1. Anne-Bursey. Silverado figure 6.1 Reflection of light. The laws of reflection are valid at each point for any reflecting surface whether the surface is flat, or curved. If the reflecting surface is flat, then incident parallel rays after reflection come out as parallel rays as shown in figure 6.2, a. If the reflecting surface is irregular, then the incident parallel rays after reflection come out as irregular rays, not parallel rays. Still the laws of reflection are valid at every point of incidence in irregular reflection as shown in figure 6.2, b. 2, a. Unit 6 Ray optics 6.1.3 of deviation due to reflection. The angle between the direction of incident ray and the reflected ray is called angle of deviation due to reflection. It is calculated by a simple geometry as shown in figure 6.3, a. The incident light is AO. The reflected light is AB. The UN deviated light is OC, which is the continuation of the incident light. The angle between AB and OC is the angle of deviation D. From the geometry, it is written as D equals 180, I plus R. As I equals R in reflection, we can write angle of deviation in reflection as d equals 180, 2i, 6.2. The angle of deviation can also be measured in terms of the glancing angle alpha, which is measured between the incident ray AO and the reflecting plane surface XY as shown in figure 6.3b. By geometry, the angles AOX equals alpha, BOY equals alpha and YOC equals alpha, all are same. The angle of deviation D is the angle BOC. Therefore, D equals 2, 6.3. 12_physics_vol2_unit 6_m.in2. The 26th of December 2022 11:37 and 18 seconds. IOCANB A D equals 182 IXYO CANB B D equals 2xy figure 6.3 angle of deviation due to reflection example 6.1. Prove that for the same incident light or image formation in plane mirror. Let us consider a point object placed in front of a plane mirror. The point of incidence is on the mirror as shown in the figure. 6.4 A B plane mirror IONIBBAAD do DI image object. Distance A I object virtual image plane mirror, B figure 6.4 formation of image in plane mirror for A point and B extended objects unit 6 ray optics 3. A light ray AO from the point object is incident on the mirror and it is reflected along AB. The normal is on. The angle of incidence equals angle of reflection. Another ray AD incident normally on the mirror at D is reflected back along the. When BO and AD are extended backwards, they meet at a point A. Thus, the rays appear to come from a point A which is behind the plane mirror. The object and its image are at equal perpendicular distances from the plane mirror, which can be shown by the following explanation. Angle AON equals angle DAO, since they are alternate angles. Angle BON equals angle, since they are corresponding angles, hence, it follows that angle DAO equals AD since the triangles AD and are congruent. AD equals therefore. This shows that the image distance DI inside the plane mirror is equal to the object distance DO in front of the plane mirror. The image formed by the plane mirror for extended object is